2.3 is factored form of a quadratic function. Okay? When we talk factored form of a quadratic function, well, before we can start talking about these quadratic functions and factoring them, we need to go in and do some review on factoring. Okay, so we're going to do some, okay, how do we solve and things like that, but we need to do some review on factoring. So that's what we're going to spend today doing is how do we factor? I'm going to go with I am reviewing Algebra 1 skills today. Okay? I'm reviewing Algebra 1 skills because you learned how to factor in Algebra 1. Do you remember all your factoring skills? Not necessarily. Wow, I didn't even hear a key on that one. You were like silent.
I took the other keys off because I was trying to make it quicker.
Still, but normally I can like hear it in the. Oh.
Yeah.
Thank you.
Is factoring where like it's like 4 plus 3 equals 7, 4 times 3 equals 12? Is that it?
Quit giving away the first problem.
Well, no, okay.
But yes, yes. Okay. So we're gonna talk factoring here. Factoring our quadratics. Before we go there, okay. First thing I always want you to get in the habit of, and I don't know, yeah, we have it happen a few times today. Always start with factoring by asking yourself, is there a GCF? Do you remember what I mean by GCF?
Greatest common factor.
Greatest common factor. So is there something that divides into all three terms? Is there anything that x squared plus 7x and plus 12 all three divide by? No, there's not. The first two divide by x, the last one doesn't. The first one just has a coefficient of 1, so there's not anything that they all divide by. So, just trying to remind you, because I sometimes forget to say that as a teacher, always think GCF. Now, after GCF, okay, this one right here is in that form of x squared plus bx plus c. And when we go to factor something like x squared plus bx plus c, I call it product and sum. Okay? In other words, you're looking for numbers that multiply to be something and also add to be something else. Okay? What's this one going to look like when we factor it? What format's the answer going to be in?
All plus.
All plus, but like... Okay, let me come back to that.
Standard form.
No, it's in standard form right now. Okay, so keep in mind, we're factoring the things that are in standard form right now. Okay, when we look at this, Eliazine was already kind of mentioning, we're going to need two numbers that multiply or have a product of the C term, which is 12, and they have to add or have a sum of what? 7. Does that sound familiar?
Yeah.
Okay, I use the word product and sum, but when I say product and sum, I'm also saying multiply and add, right? So I need two numbers that multiply to be 12 and add to be 7. Now, some of you, you've got them right already, don't you? The moment I said it, they were there, you're good. Okay?
Oh.
Now, some of us don't have them yet, or maybe we have this one, but we don't always get them as quick. If you're one of those people and you're like, okay, these take me a moment, here's what I'm always going to suggest. I'm always going to suggest make a list of your products. So what are the pieces that multiply to be 12?
2.
2 and 6. 4 and 3. 3 and 4. There's always a 1 and itself, right? So I always, if I'm confused, if it's a bigger number or a number I'm not sure about, or I just am not finding my answer mentally, I'm going to start at 1 and 12. 2 is 2 times 6. 3 is 3 times 4. And then when I get to 4, what do you notice? We already have 4 here, don't we? Okay, so my answer's got to be in one of these pairs. Which pair that multiplies to be 12 also adds to be 7? We're using 3 and 4, yes? Okay, now this is what I was trying to answer or ask earlier. What's the format? My answer is not just 3 and 4.
X.
Or the pair.
Excuse me.
Okay. So when you're factoring a trinomial like this, and we're doing product and sum, we're looking for 2 parentheses. Okay, 2 parentheses. X squared. What's x squared always going to break up to in these situations?
X.
X and x, yes? That's always where we start. And then your numbers.
Oh, the pluses. Doesn't it change if it's like a plus and a minus?
Yeah.
That's what I said.
Your numbers go right there.
That's what I said.
And in this case, we're multiplying to be a positive and adding to be a positive, so both numbers are a positive. So x plus 3 and x plus 4. Now, I wrote mine as x plus 3 first and then x plus 4. Does it matter if you wrote the x plus 4 and then the x plus 3? It does not matter the order you put your parentheses as long as you have the same 2 parentheses. Even Savas doesn't care which order you put it in. Okay?
That's
There's actually things Savas is somewhat flexible on occasion. So,
I couldn't have it because like plus minus. I remember Emma would always.
now, and this may be something that I teach slightly different than Mrs. Rogers in terms of the signs. I mean, I'll teach it, but I may teach it slightly different than hers. So, okay. Are we ready for the second equation?
No.
Yeah.
Yeah, we are. Okay. 2x squared minus 5x minus 3. What's the first question I ask you to think about every problem? When you're factoring,
The
start
GCF.
by, is there a GCF? Is there anything that divides into all 3 terms?
No.
There's not, is there? Okay. Now, as we go to think about factoring this, what's different on this one?
You gotta subtract to it and add to it. I don't know.
But it's just an expression, so I can't subtract to it and add to it.
2 in the
What'd you say?
There's a 2 in the front.
There's a 2 in the front, yes?
Yeah.
Okay. That creates a difference in our problem. Because here's the deal. That 2 out front means I can't just jump to 2 parentheses and say, oh, it's x times x. Because there's a 2 there now. So we have alternate methods we use here. And this one I know my primary method is very different from Mrs. Rogers' primary method, but I'm going to teach both. Do we remember what she taught?
You just divide
Or
it.
Mr. Weaver, I guess.
Well, that was too long ago.
You just divide it.
Yeah. Okay. So this one I call product and sum. I personally like to teach product of AC here. And I'm going to teach that. Mrs. Rogers would use slip and slide on this.
Oh, I like that.
I hated that.
I like slip and slide.
Now, okay, so here's what I'm going to do. I just learned slip and slide last year. I don't necessarily have the right vocabulary, but I know how to do it. Okay? Mrs. Rogers taught me the basics of slip and slide. So she taught me last year too. With this in mind, I'm going to show both. Do I care what you use? No. Okay? So with that in mind, I'm going to start with mine. And then you can decide whether or not you like mine or not. And if you don't like mine, guess what? Or review slip and slide. Fair enough?
Yeah.
Now, keep in mind, we're doing this because this one is of the form ax squared plus bx plus c, right? Where this one over here was just a 1x squared plus bx plus c. So I'm going to start with a product, and I call it product of AC because we're going to start with a product of AC. What are A and C?
2 and 3.
2 and more specifically, -3. What's 2 times -3? -6. So product of -6. And for your sum, it's still a sum of the B terms. Or of the B term. What is B?
-5.
-5. So I need 2 numbers that multiply to be -6 and add to be -5. This is a tricky one when it comes to 6s and 5s, but what are my options for multiplying to be 6? You could say 1 and 6 or 2 and 3. Now, here's the catch. Since we're multiplying to be negative 6, how do you multiply to be a negative? You need a positive and a negative, yes? Okay, now, somehow, in each of these pairs, we have to make one number negative, and we need our sum to be negative 5. So how do you make one number negative and have a sum of negative 5? Which pair are we using? 1 and 6. We're going to have to use the 1 and 6, and how do we use the 1 and 6? Okay. Negative 6 plus 1. Check the math with me. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5, right? Okay. Now, with this, here's what I'm going to do. And this is the part, I'll be honest, I'm not sure how Mr. Weaver, I don't know if anyone had Mr. Weaver for Algebra 1 in this class, but I don't know how Mr. Weaver teaches, if he was slip and slide or product of AC or what he did. I don't remember. So, but what I'm going to start off having you do, those two numbers we just came up with, the 1 and the negative 6, right? We're going to take them and we're going to split our middle x term here. And we're going to split it into 1x and minus 6x. So I'm going to have and it's a positive one, right? So a plus 1x minus 6x. Now, my first term still carries down, 2x squared. My last term still carries down, minus 3. I feel like I wrote really small there. Do I read it?
Yeah.
I'll write bigger on the next line, sorry. Okay, so all I did is I carried the first and the last term. I split my middle term, yes? Now, how many terms do I have? I went from having 3 terms to now I have 4 terms. So what we're going to do is we're going to take these 4 terms and we're going to split them in half. We're going to split them into 2 groups. Officially, this is called factor by grouping. Okay, I'm going to split them into 2 groups. So I'm going to split right after the second term. And now we're going to talk GCF. What is the GCF of the first 2 terms? 2 and 1 both divide by 1. What about the x's though? Do they have any x's in common?
So it's 1x.
Here we have an x squared. Here we have x to the first, so they both have at least one x. So we're going to factor out a GCF of x. Or 1x, you can say, if you want. When I say factor out GCF of x, what's that mean I'm doing to these 2 terms? I'm going to take these 2 terms and divide them by x. So what is 2x squared divided by x? 2x plus, what is 1x divided by x? No, 1, because the x's cancel. And now, I don't know, do we need the visual? The visual is that I divided both of these terms by x. That's the visual. You don't have to show that by any means, but okay. Now, repeat, second half. Negative 6x minus 3. What does negative 6x and minus 3 both divide by?
3.
They divide by 3. We're going to have 2 in our answer, yes? Now, they're both negative. So let's use negative 3. And here's what I'm going to say. Anytime the first number is negative that you're trying to factor out of, use negative 3. So right after where this parenthesis ended, I'm going to put negative 3. And now, what is negative 6x divided by negative 3? 2x. What is negative 3 divided by negative 3? Plus 1. And again, if it helps, what did we just divide both of these by? Negative 3.
So when it cancels out.
What? Talking about the 2x plus 1s?
No, like the negative 3 and negative
Well, when you divide them, there's still something left. If you have 3 divided by 3, it's still 1. Okay? Okay, now, all I have to do is write my final answer. I know I'm on the right track. Did you notice my parentheses are matching? They should match. I want them to match.
Oh,
Okay? They don't cancel out. Here's the deal. My final answer here looks just like my final answer did on the first one. We can look at, it doesn't matter which order you do this. One of your parentheses, right here, are the GCFs. What were my GCFs? X and minus 3. That's one of your parentheses in your final answer. The other parenthesis is the matching parentheses. The matching parenthesis was 2x plus 1. So that 2x plus 1 represents the match. The x minus 3 were the GCFs. That is factored. Okay? So it still factors into 2 parentheses, 2 binomials. It's just we can't just go product of A or product and sum. We have to think the AC route. Now, some of you are okay with that. Some of you are thinking, I'm not sure yet. Your call. Should I demonstrate slip and slide as a reminder on this one too?
I don't want to
no, because I'm gonna get mixed up.
Well, and here's the thing. I want to demonstrate both because I do know some people definitely do end up preferring slip and slide, I've discovered.
Go to the next one. Or the same one.
I was going to do this one same method so you can see them side by side. Do we have room? I don't know if I have, you know.
I can do it.
And I'll be honest, this next one down here isn't going to take as much room. So if I run down into it, you know, I'm not going to be too concerned. No, maybe it's not a good idea for me to teach these side by side. Last year, I think I taught slip and slide after the fact. So I don't know. What it's going to come down to is eventually pick your method and you stick with it. So after you've kind of seen them both, on the next one we do, I'd say pick a method and stick with it. Now, okay, slip and slide. With slip and slide, again, it's the same thing when you have an A value out front, yes? And I don't know the vocabulary exactly, but you take this front 2, and I don't know if we're slipping or we're sliding it, but we're going to slide it over to the negative 3. Okay? So if I slide that first number over to the negative 3, my front becomes x squared. It's still minus 5x. And what is minus 3 times 2? Minus 6. Now, this problem looks more like my first problem, yes? Where you can go straight into 2 parentheses. Okay? X squared, what did I talk about earlier? X squared breaks into x and x. What numbers multiply to be negative 6 and add to be negative 5? Is it the same numbers from above? Weren't we multiplying to be negative 6 and adding to be negative 5 earlier? So we already did that work. Those numbers are plus 1 and minus 6, right? Now, with slip and slide, you have one extra step here. Earlier, we slid the 2 over here, yes? Now, since we multiplied the 2 over there, we have to divide the 2 out of these factors. Okay, so you multiplied it in, now I have to divide it back out. With that in mind, 1 over 2 Can 1 over 2 simplify? No, it's just 1/2. So we don't want a fraction answer here. So what we're going to do is we're going to take this 2 and we're going to write it out front. And so then we're going to write this out front as, put the 2 out front, so 2x plus 1.
Yeah.
Does 6 over 2 simplify?
Yeah.
Yeah, 6 over 2. If it can simplify to a whole number, simplify it. 6 over 2 is 3. So we have x minus 3. What do you notice? We got the same answer, yes? Does that sound familiar?
Yeah.
Maybe I taught it slightly different than Mrs. Rogers, I don't know. But the concept is the same, I know. Okay? I'm fine with either method. I'm more of a product AC girl personally. And I guess that's more because as my students like go to calculus and stuff, I like them to know, more of the official, but slip and slide works. Not against it. Questions there?
Penny sticky note.
There you go. Okay, let's keep going. Okay, my plan was to get all 6 of these done. I guess I should have not wasted time at the beginning of class. Yeesh. Okay, ready for the next one? 3x squared minus 18x minus 48. What's your first question on every problem?
GCF.
Is there GCF?
No.
Yes. It is 6.
Can't be 6
It's too big.
because my smallest number here is 3.
So it's 3.
The biggest it can be is 3 because that can only be as big as your smallest number. Do all of those divide by 3.
Yeah.
Yeah. And if you're not sure about that last one, throw it in the calculator, yes?
It's 16.
Okay. So, first thing we're going to do is we're going to factor out a 3. Okay, so GCF actually works this time. When you factor out a 3, you're dividing everybody by 3, yes?
The question mark.
Yeah, like in other words, it was GCF question mark. Like that's what we're asking ourselves. This time there is, what are we going to do? We're going to divide everybody by 3. When you divide everybody by 3, you have to put that 3 out front. Then, in parentheses, what is 3x squared divided by 3?
X
Minus, what is 18x divided by 3?
6.
Minus, what is 48 divided by 3?
16.
Okay, so always, first step, look for your GCF. Now, am I done? Maybe, maybe not. The good answer is no, because we need to check and see, is there more factoring? Is it possible x squared minus 16x minus 16 could factor again? Yeah, because it could possibly go into 2 parentheses, like what we've been doing. Now, here's the nice part. We factored out that 3. This is now a 1x squared. Do we have to use our long method of product of AC or slip and slide? No. We can go just to what we did on the first one, can't we? Where, what are we going to need a product of? Go with what we have. Product of negative 16 and a sum of negative 6. Okay, if you're not sure, ask yourself what multiplies to be 16.
2 and negative 8. 1 and 16.
1 and 16, 2 and 8, and 4 and 4. And 3 doesn't go, right? Those are my choices. Which pair can give me the 6? The 2 and 8. How do we make this work? If it multiplies to be negative, one of my signs is negative, because positive times negative is a negative. If it adds to be negative 6, it's going to be negative 8. I always say if it adds to be, if you have 2 opposite signs, and it adds to be a negative, the larger number is a negative. Okay? So, okay. What about this 3 out front? Stays. Don't lose it. That'll cost you a point. Slavis will just tell you you're wrong. Then, x squared minus 6x minus 16 breaks up into 2 parentheses. X squared.
It's gonna be like a plus or minus.
X squared breaks up into x and x. And then my numbers that go in here are plus 2 and minus 8. Okay. What about x squared minus 9?
I'm thinking it's gonna be like
Maybe 3.
10 and 1, or like 1 and negative 10.
If it's, first of all, 10 and 1 don't multiply to be 9.
Oh shit, you're right. But I did. So it's gonna be 3 and 3. It's gonna be 3.
3 and 3. And here's the deal. We have, what are we missing here? We don't have a middle x term, do we? Right? We have that negative 9, but we don't have a middle x term. So I don't necessarily teach it like this way, but could you ask yourself what multiplies to be negative 9 and adds to be 0? Okay? So I agree with the 3 and 3. I teach this as difference of squares. And the idea here, yes, we're going into 2 parentheses. X squared. How am I always going to tell you that breaks up? X and x. X is also the square root of x squared. What's the square root of 9?
3.
3. So what are we going to use here? 3 and 3. How do you multiply to get a negative 9? You need a plus and a minus. And what does that plus and minus do then? You would end up with no middle term, which I haven't talked about. Could we FOIL to check these?
No.
Let's not.
No.
We can. I haven't been, and I don't necessarily do it, you know. I guess what I'm going to say is I don't require you to do it that way. If you bring me something and say, I don't know if this is right, that very well may be what I quickly do in my head to check, is FOIL it back together. But what I would remind you here on this one, this was what I call difference of squares. So if you ever hear me talk about difference of squares, and officially what we did is the square root of x squared was x, and the square root of 9 was 3. Okay? So difference of squares. It always works when you have difference being subtraction, right? The subtraction between 2 perfect squares. Okay. I guess it was an easy Friday. We're like a minute and a half from the end of class or so. So, I'm going to pause there because the next one is a big one. And we will practice factoring on Monday. Maybe I'll start off Monday and say, okay, factor the first problem for me.
I can do
It
it.
is doubtless. I'm failing this class. It is.
No, you're not. It is doable, especially when you have your notes here. Okay, over the weekend, finish up any missing solves. That's your homework.